Welcome to the tutorial on right-angled trigonometry. What do we know about right-angled triangles? Well, you may be familiar with Pythagoras' theorem. It states that a squared plus b squared equals c squared. The other thing that we may know is that there are Pythagorean triples. If a equaled 3 and b equaled 4, then what is c? Well, c squared equals 25, or we can put it as 5 squared. So the Pythagorean triple is 3, 4, 5. That's a special right-angled triangle. And there are other combinations of numbers, just like 3, 4, 5, that make up other Pythagorean triples. That's wonderful, but what if we want to know what the angles are? So if I want to know what this angle is or that angle, how do I find that out if I'm given A, B, and C? Or what if I'm not given those side lengths of A, B, and C, but I'm given what the angle is? How does that help me, and how do I use my math to figure it out? There's actually an acronym, and it's a well-known acronym. Some of you may have heard it, some of you may have not. It's SO, CA, TOA. And for this video, I'm going to focus on TOA. And what exactly does that mean? What we're discussing is the tangent ratio. Now, if I'm given triangle ABC, as you see here on the left, and I want to find out what angle A is, how do I do that using the tangent ratio? The tangent ratio states that my opposite length and my adjacent length are going to be used to find the tangent ratio. So that means I'm going to write it as tan A, because the angle I'm trying to find is at A, equals the length of side opposite angle A divided by the length of side adjacent angle A. Now, commonly we use uppercase letters for the vertices, as you see with A, B, and C, and in my other triangle, G, H, and J. Usually, when I say usually, we use Greek letters for the angles themselves. So I might have theta, or I might have alpha, and sometimes beta is used as well. It makes it easier. Theta is the most common, but you will see beta and alpha or other Greek letters for the angles if we're having more than one that we're dealing with. For the demonstrations in this video, I will usually use theta. So, if I would like to find angle theta, which is right here on triangle GHJ, and if I gave you that the length of GH is 5 and the length of HJ is 4, how do I find angle theta? First of all, you're going to need your calculator. So when you have your calculator, I want you to check, and this is just an aside. So you're going to check your calculator that it is set for degrees, not radians. And that's because I want to find the degree of the angle. So you have to make sure that your calculator is set for degrees. Now, you can do a quick check. And the best way to check, for your check, I'll put this in black so you know you can do a check. Check your calculator. You're going to put sine 30 and find out the answer. Now, if you hit the SIN button and then hit 30 and hit enter, you should get 0.5 or 1/2. If you get this as an answer, then you know, yes, my calculator is in degrees. If you do not get that, then you are in radians and you'll need to go into your settings and change your mode to degrees. Now, if you need to do that now, pause the video, check your calculator, and come back for the rest of the tutorial. Welcome back. You've set your calculator to degrees. Now let's actually work with GHJ right-angled triangle. Now, I know to find tangent ratio for theta, or G, it's going to be my opposite, which is HJ, length, divided by the adjacent, which is GH. So that angle theta, so I'm going to write it, I put angle G, that's one way to write it, the other way is theta. I have the length of HJ is 4, and the length of GH is 5. Now, how, Miss Carla, do I put this in my calculator? To put it in your calculator, it's going to seem a little bit strange. You're actually going to hit the tan inverse button. It's usually in second mode on your calculator, and then put in 4/5 to find out what the angle is. And you'll find it should come out to 38.7 degrees, and I am rounding here. Now, why am I putting the inverse of tan? And that's because I need to find the degrees. If I had known that theta equaled 38.7, so let's draw another triangle here, and I said this angle theta, where theta equals 38.7 degrees, how do I find the lengths opposite and adjacent? Well, actually, I'm going to put in my calculator tan 38.7, because that's my degrees, and I'm going to come up with a number. So if you hit tan and then 38.7 in your calculator, hit enter, you're going to get 0.8, and it's 0.1, blah, 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 blah. So we're going to round it to 0.8, which we know 0.8 equals 4/5. So that means that opposite is 4 and adjacent is 5. How do I exactly know it's 4/5 and not 8/10? For the angle, if you put tan inverse 8/10, you'll get the exact same answer for theta. It'll be 38.7 degrees. This triangle here and this triangle here are similar triangles. The angle will not change, even though the length of our sides changes. So that is important to remember, that if the lengths of sides change, the angle degree does not. So as long as we can come up with 0.8, which is our opposite over adjacent, then the degree, when I put in my inverse tan, will always come up with 38.7.